Good morning, ladies and gentlemen. Today we are on page 107 of our student journals, and we are actually doing one of my favorite lessons of this unit. So we're doing something called prime factorization. So our objective today is, today I will express a whole number as a product of its prime factors. Okay, so let's kind of talk about what that means. So today I will express, it just means to show a whole number as a product. Product, remember, means multiplication of its prime factors. Okay, so let's look at our vocabulary here. Our first two words are reminding us what a prime number is and what a composite number is. So a prime number is numbers that have only two factors, one and itself. So 2 is a prime factor because prime number because the only way I can get 2 is by saying 1 times 2. I can't do any other way. 3 is 1 times 3. 5 is 1 times 5, 1 times 7, 1 times 11, 1 times 13. The reason 1 is not considered a prime number is because 1 only has one factor, and a prime number has to have two factors. So 1, the only way I can multiply to get to 1 is 1 times 1, which means its only factor is 1. A composite number is numbers that have more than two factors. So 4, how can we get to 4? We're going to put a little note here. 4, we could say 1 times 4 and 2 times 2. So 4 actually has 3 factors, 1, 2, and 4. Okay, let's look at 6. 6 is not prime because 6 we could say 1 times 6 and 2 times 3. So 6 has 4 factors, 1, 2, 3, and 6 all fit perfectly in. I think of factors as fitting perfectly in. Okay, our big thing today is we're going to make something called a factor tree. Okay, so a factor tree. Now, there are some steps here. We're going to follow their steps, but I'm going to make some rules added. So when you make a factor tree, here are some rules we're going to follow. Ready? No ones allowed. No ones allowed. We can't use a 1 in our factor tree. Now, obviously, there's a 1 in the number 10, but that's not considered a 1. So when I say no ones, I mean no just plain ones allowed. Okay, our next rule is all branches end in apples. Okay, so this is just my silly little phrase, all branches end in apples. We're calling these lines branches, and we're calling these circles apples. Those are my apples, okay? So all branches have to end in an apple somewhere. Okay, those are pretty much our two big rules. So no one's allowed and all branches end in apples. Okay, some other things that you're going to notice, it's not necessarily a rule, but something that you're going to notice is there's many right ways to get to the right answer. Yep, that will work. So I'm going to show you how, if you were to do this with a friend, you might get the right answer and your friend might get the right answer, but you might have got there differently. Okay, so I'm going to get started, okay, with mine. And I want you to keep in mind what this factor tree kind of looks like in my rules. No one's allowed and all branches end in apples. Okay, so here's my first problem. My first problem is just 12. They want me to make a factor tree for 12 and then write this using its prime factors. Okay, so 12 is going to be the top of my tree. And I'm going to ask myself, how can I break 12 up? How could I say blank times blank gets me 12? What could I use? I could say 1 times 12, but I can't because ones aren't allowed in my factor tree. So what else could I say blank times blank gets me 12? I could say 2 times 6 gets me 12. So I could say that. Okay. What about 2? What could I say for 2? 2 times what? Or what times what gives me 2? Ooh, I can't. You know why? The only way I can get 2 is saying 1 times 2, and ones aren't allowed, which means I am done. And I just realized, ladies and gentlemen, I'm using green. I should be using red. I'm sorry about that. So I can't break 2 up without using a 1, so it's going to become an apple. What about 6? What could I say? What times what equals 6 without using a 1? I could say 2 times 3 equals 6 without using a 1. Okay, what could I say about 2? What times what equals 2 without using a 1? Can't do it, so it has to become an apple. What about 3? What times what equals 3 without using a 1? I can't do it either. Okay, so did I follow my rules? Yes, I used no ones, and all my branches ended up ending in apples. Now what I do is I write these prime factors in something we call prime factorization. I just take them and put them in order using multiplication signs. So 2 times 2 times 3 is the prime factorization of 12. Now I could have done it a different way. So remember when I said there's different ways to get the right answer? What if I was thinking, how could I break up 12 without using a 1? What times what equals 12 without using a 1? What if I decided to say 3 times 4? 3 times 4 equals 12. So I could have done it that way. And then I could ask myself, what times what equals 3 without using a 1? Not possible. What times what equals 4 without using a 1? 2 times 2. What times what equals 2 without using a 1? Nothing. What times what equals 2 without using a 1? Nothing. So look what happened. Even though I did the 12 differently here, look at my we're going to call them our little apples. They're the same. I have 1 3 in each of them and 2 2s. When I write my prime factorization, I usually put them in order from least to greatest. So I have 2 2s and 1 3. So my answer's the same even though my work was different. Okay, and you might see that on a lot of them, is that your work might end up different than someone else's, but your answer will still be the same. Okay, let's look at one more of mine. My next number is 8. Okay, so 8's going to be the top of my tree, my factor tree. What times what gives me 8 without using a 1? 2 times 4. Okay, what times what gives me a 2 without using 1? Nothing. What times what gives me 4 without using a 1? 2 times 2. And I've already realized that 2s I can't break apart. They're stuck. So all my branches ended up in my little apples. Now I'm going to take these prime factors and put them in order with multiplication signs. So my prime factorization of 8 is 2 times 2 times 2. Okay, ladies and gentlemen, let's try some of these together. We're on page 108, and here is our first one. And we're actually going to do this one twice, so I want you to take your paper and cut it in half, because I want us to practice how there's different ways to do it. Okay, so our first number is 16. Now, we're doing these together, remember, so you shouldn't be going ahead of me. So what times what gives me 16 without using a 1? We could say 2 times 8. Okay, and you've probably already seen for mine, 2s don't work. 2s become apples. So what about 8? What times what equals 8 without using a 1? Wouldn't that be 2 times 4? And my 2 becomes an apple. Okay, what times what equals 4 without using a 1? 2 times 2, and our 2's become apples. So all of our branches ended up ending in apples. And what do we have? 1, 2, 3, 4 2's. So 2 times 2 times 2 times 2. That's our answer. What if we had done it a different way? How else could we have broke up 16? What times what equals 16 without using a 1? Could we have said 4 times 4? Definitely. And then what would happen to our 4's? 2 times 2. And what happens to 2's? They become apples. And wouldn't that 4 also be a 2 times 2, which become apples? So our trees look different, but look at our answers. The same thing. We have 4 2's. So our answer becomes the exact same. And I just realized I wasn't pushed up enough. I'm sorry, ladies and gentlemen. Okay, let's look at our next one, and we're going to do the same thing. We're going to do it 2 different ways. So please divide your section in half. And we're going to do 2 trees for 30. Now you don't have to always, you don't have to always do 2 trees. I just want you to practice how it could be different. Okay, so how can we break 30 up? What times what equals 30 without using a 1? Could we say 3 times 10? Okay, what times what equals 3 without using a 1? Nothing. What times what equals 10 without using a 1? 2 times 5? Okay, so 2's become apples. What about a 5? Hopefully you're realizing 5 becomes an apple, because I can't say nothing times nothing equals 5 except 1 times 5. Okay, so when I write my apples or my prime factors, I get 2 times 3 times 5, and that's my answer. Okay, let's try it a different way. What if instead of saying 3 times 10, what if we had said 5 times 6 will give me 30? Okay, we already established that 5 becomes an apple. What about 6? Could we say 2 times 3? And then I know 2's become apples and 3's do. So what's my answer when I take my 3 prime factors or my apples? I get 2 times 3 times 5. So again, I get the same answer even though my work there was different. Okay, ladies and gentlemen, I hope you're like me and you really like prime factor trees. I think they're pretty fun. Have a great afternoon. Bye-bye.